Hello, welcome to the part 2 of building interpreter for Python. So in last video we have built the lecture or the tokenizer for our mini Python, and now it can output the character tokens. So you can see it now can parse the characters or the source code into the tokens. And in this video I want to talk about the design of AST node. So why would we need the abstract syntax tree node? Because we only can produce a set of tokens, but the meaning of a single token cannot help us evaluate the value for the interpreter. So before implementing the parser, we first need to define the syntax tree node to let the later phase to evaluate all the nodes. So AST node is, in one word, we want to use a finite set of rows, set of tree nodes to express an infinite code structures. So for Python code or any language code, there will be many lines code looks, or the code is so many. But if we look into the code, we can see it mainly can be categorized into two kinds. First is the expression is computations that evaluate and returns a value, and the second kind is statement is action that controls the flow of the program or have a steady effect. So no matter how much the code can eventually be treated these two kind of state to know syntax node. Now the question is, since how do we express the T node in Rust? First question is what kind of data type we use to define the AST node, and the second question is how do we define the AST node. The first question is pretty straightforward, because as we can see there are only two types of node. So even though each type has many concrete types, and to represent the different kind of data type, you can use Rust enum, because Rust enum allow us to write different kind of data types in one data structure. The second question, how do we define the T node? So for this question, there are two issues we need to resolve. First is because the tree node is a recursive data structure, so we need to know how to define the node in a recursive way. And another question is how we know what kind of specific node we need to define in the statement or in the expression. So for the first question, how do we express recursive in Rust? So for Rust, it need to know the insize compile. So let's see example code. So suppose we want to implement a binary tree, and it has a root value and left right subtree, and for a node it has three fields: value left, and the node it in the left, and the node in the right. And now we can see the compiler has an issue is recursive type node has infinite size. So we need to wrap the node in box. If you wrap the node in the box smart point, the compiler can know the size at compile time. So for our abstract syntax tree, when we want to express recursive, we will wrap the data structure in box. So for second question, how do we know what kind of statement or expression we should define in our interpreter? This actually is straightforward, since according to the types of node, statement is actions that control the flow. Expressions will evaluate to a value. So we can check the syntax rules and map every kind of statement into a specific syntax node in the node inner. So you can see we map the specific rule statements into statement inner, and for expression we apply the same way to map the expression in grammar rules to our expression in the main Rust. Let's check the lambda. So for expression, it has a lambda expression or assignment. Let's see how we can define the lambda. So it has a lambda keyword and then a set of parameters and an expression. So this is straightforward for us, and according to this rule, we know a lambda expression contains two parts. First is a parameter, second is expression. So we can define in this way. It has a parameter list, which is a vector of string, and a expression, which is also a expression, which wrapped in a box. And then let's see how the assignment. So assignment is assignment target, assignment operator, and assignment expression. So we can express it in target, assignment targeter, and assignment operators to contain all the operators described in the EBNF rules. And the assignment right hand is an expression. So let's see a specific example of how we'll express a simple. Suppose we will output a abstract syntax tree for this expression. So we know it's is a expression first, and now we can group it into a expression like expression and expression binary expression, which the left hand expression is literal 1 and the operator is plus, and the right hand is another binary expression. 2 operator is multiply 3. So you can see our final result of abstract syntax tree for this expression 1 plus 2 multiply 3 expressed in a recursive way, because multiply has higher precedence than plus. So our expression is outcome is express the 2 and 3 in another binary expression.